Hello everyone, I'm very glad to share my research here with all experts and scholars. I'm Ningshuang Zeng from the School of Civil Engineering and Southeastern University. My research topic is process coordination and automation in modular construction supply chain using smart contract and RPA. While the modular construction is a big topic in recent years, my research focuses on the supply chains of modular construction. Basically, from off-site manufacturing to the boundary-spanning logistics and finally to on-site construction, there are a series of existing problems. First, on and off-site process fragmentation, which is the underlying problem due to the different production methods. Second, delays in lead time. Third, wastes in the material flow, for example, overstock in warehousing. Then, invisibility in the information flow. And finally, low automation in the transaction flow. Currently, there are also a series of technological enablers to help solve this problem. Information and process modeling techniques can help build and simulate the connection between on and off-site domains in a digital environment. Then, process automation and sensing and tracking technologies such as RPA, AI agents, and IoT devices can help automate and optimize the material flow. With the help of blockchain and smart contracts, the information flow and transaction flow can be more visible and secured in an automatic or semi-automatic way. Facing these challenges in modular construction supply chains and with these technical innovations, this paper aims to make efforts in two aspects. From the technical perspective, this paper aims to develop an upgraded workflow engine that combines blockchain-enabled smart contracts, RPA, and related modeling and visualization technology to address these coordination challenges. From the managerial perspective, this paper aims to design a managerial object that carries all the necessary information and the smallest unit of coordination, and also as the smallest unit driven by the developed workflow engine. The method we propose in this paper is also from both managerial and technical perspective, as you can see in the left side of the slide. And the first stage is modular construction supply chain modeling and conversion. And you can see in the right side, there's a process model in BPMN format. It involves multiple participants along the supply chain, such as a building component supplier, a quality test center, a logistic supplier, and a construction contractor. It completely reflects the realistic activities from order placement to manufacturing, delivery, and final installation on-site. And the next step is to convert this process model into smart contract code. The details you can find in our previous research paper. This paper also provides an open source tool for the conversion. Then move to stage 2, supply chain coordination configuration. The core of this stage is to define the modular construction supply chain supply batch, MSB. As you can see, this supply batch contains all essential attributes for coordination, and it is extensible. Meanwhile, this batch is linked with the B model. Another two essential aspects are location-based linkage and order-based linkage. The location-based linkage is the combination of the project WBS model and the B model. Here, this example, MSB is linked to the construction zone, first floor, zone A. And the order-based linkage is just like putting a token on the process model to execute. In practice, for the supplier, one order usually is not one delivery, can be more. And for the construction manager, he doesn't care about every delivery or every order, but cares about the construction zone, just like is the first floor completed, which part is delayed. Therefore, we design this MSB so that the construction manager can define it. For example, one MSB is the batch, as you can see in the green highlighted in the BIM model. The construction manager can control this batch, and he can know which order this batch belongs to, and he can also know how many deliveries are included in this batch. He can check this MSB status according to the real-time updates from the process model, which is already executed as smart contracts. The final stage is the process automation. The core of this stage is to develop RPA actions and integrate them into the coordination process. As you can see on the right side, there are several example RPA actions, such as RPA warning. This is the automatic prediction according to the planned production date and the actual production date. If the supplier has unacceptable delays in production, which exceed the time buffer of the contractor, the RPA warning action will report this situation to the contractor to avoid actual construction delays. In this system, as you can see on the right side below, the supply bench table, process model, and BIM model are updated at the same time to support the coordination, and all process status is secured via the underlying blockchain. Well, a real-world case study in China is conducted to validate this method. As you can see, after using this system, the key indicators have been improved. For example, the order to delivery lead time is decreased, and the accumulative supply delay time is sharply decreased. Meanwhile, the coordination negotiation time per week is also obviously shortened. In conclusion, this study proposed a blockchain-enabled smart contract and RPA integrated method to improve the modular construction supply chain coordination. The proposed system innovatively incorporates with the practice-oriented approach to MSB-based management, drawing on industrial insights to define MSB and the basic coordination unit within process execution. And for the future works, from the technical perspective, future research will focus on enhancing the current method by incorporating AI workflows and upgrading the RPA actions into AI agents. And from the managerial perspective, future work will also explore the integration of buffering strategies, early warning mechanisms, and adaptive monitoring methods. There are references in this paper. Thank you for listening, and any feedback is highly welcome.